let me explain how to find the integrating factor f for the given ODE. If you remember the exactness condition, we can use that here. So dm over dy is dn over dx. From the same context, we could have, in our case, m was fp and n was fq. So we could have the same condition. And if you do the partial differentiation of this, that's df over dy times p plus f times dp over dy. And on the right hand side, df over dx times q plus f times dq over dx. Full chain rule. But this equation is solvable, but simply too complicated. We may not be able to handle it properly well. So we have to make a judgment that we assume either f to be f of x or f of y, not f equal f of x comma y. This is too much complicated. So let's take it that f is either f of x or f is a function of y. So let's say you choose f to be f of x. Then we call the method 1, which is f to be f of x. So the partial derivative of df over dx is simply f prime, is total derivative, right? So df over dy is 0. And we can simplify this term using these zeros, okay? So df over dy is 0. We have this 3 term left, f dp over dy equal df over dx q plus f dq over dx. By putting all the f terms to the left hand side, you'll get this. That's 1 over f df over dx equal 1 over q times dp over dy minus dq over dx. And this complicated term we could specify as r of x. And then it is separated actually. Since it is separated, we can get f by integrating both sides, and f of x equal exponential to the integration of r dx. And that's f what we get. This term r seems to be very complicated, but if it's an example problems, then you get a clear vision on that. On the other hand, you could possibly choose f to be a function of y. In that case, that'll be our method 2. When you choose f to be a function of y, we have df dx is 0, df dy is f prime, and we put them here, and then we get df dy plus times p plus f dp over dy equal f times dq over dx this time. Same method, putting all the f terms to the left hand side and the rest term to the right hand side. We get this, and we assign same thing out of y this time. This is a function of y, okay? And then it's separated again, so we get integrand on both sides. So f of y is exponential to the r of y this time. Okay, that's our f of y. So how can you choose f to be f of x or f of y at the beginning? You simply choose either one and then try to solve it. And if you can solve it appropriately, then that's it. But if it does not solve in that way, that selection, then you should go back and choose the other method and solve it. Then it'll be solved.